Okay, so for this video, I'm going to be talking about positive and negative selection of thymocytes. And so thymocytes are hematopoietic progenerator cells present in the thymus. So there is positive and negative selection. So first I'm going to talk about positive selection. Thymocytes, which pass B selection, express a T cell receptor which is capable of assembling on the surface of a cell. However, many of these T cell receptors will still be non-functional due to the inability to bind to MHC. And the next major stage of thymocyte development is the positive selection. So the job of positive selection is to keep only those thymocytes which have a T cell receptor capable of binding MHC. And so, like we just said, it's non-functional because they can't bind MHC. So the job of the positive selection is to keep only those thymocytes that can bind MHC. T cell receptors require CD8 as a co-receptor to bind MHC class 1 and CD4 as a co-receptor to bind MHC class 2. And at this stage, thymocytes upregulate both CD4 and CD8, becoming a double positive cell. And the double positive thymocyte undergo commitment, maturing into a CD8 plus T cell, which recognizes the MHC class 1, or a CD4 plus T cell, which recognizes MHC class 2. And then lineage commitment occurs at the late stage of positive selection and works by downregulation of both CD4 and CD8, which reduces the signal from the T cell receptor, and then upregulation of CD4 only. So we had upregulation of CD4 and CD8, which made it a positive or a double positive cell. And then you had downregulation of both CD4 and CD8, reducing the signal for the T cell, and then only upregulation of CD4. So CD8, there is no upregulation. And then thymocytes start receiving signals again, are those that receive MHC class 2 and they had become CD4 plus T cells. So if they start receiving the signals, they're the CD4 and not the CD8. In the thymus, thymocytes come into contact with thymic epithelial cells that express high levels of class 1 and class 2 MHC molecules on their surface. And these self-MHC molecules present self-peptides, which are typically derived from intracellular or extracellular proteins, and they are degraded in the normal course of cellular metabolism. If a CD4 plus or CD8 plus thymocyte recognizes a self-MHC peptide complex on the cortical epithelial cell that they are browsing, it will undergo positive selection, a process that induces both survival and differentiation of DP thymocytes. And then newly generated thymocytes do not successfully engage the MHC peptides they encounter with their TCRs. So either they have not generated a functional TCR alpha-beta combination, or the combination does not bind MHC peptide complexes with sufficient affinity. So these cells have failed the positive selection test and will die with apoptosis within 3 to 4 days. So like I said in a couple of my other videos, apoptosis means programmed cell death. So if they fail, they will die through apoptosis. Without positive selection, the system would be cluttered with a great deal of cells. They are unlikely to recognize anything and reduce the probability that a T cell will find its antigen in a reasonable amount of time. So, negative selection, there is success in positive selection that allows the thymocyte to undergo a number of maturational changes during the transition to a single positive T cell. So the single positive T cell upregulate the chemokine, and those are a family of small cytokines or signaling proteins that are secreted by cells. And then the chemokine receptor CCR7 causes a migration from the cortex to the medulla. At this stage, the key maturation process involves negative selection, and the elimination of autoreactive thymocytes. So negative selection can occur at the double positive stage in the cortex. Negative selection is not always 100% effective, and then some autoreactive T cells escape thymic censorship and are released into circulation. So autoreactive CD4 and CD4 plus and CD8 plus thymocytes with high affinity receptors for MHC self peptides combinations are potentially dangerous to an organism, and many are killed by negative selection in the thymus. And errors in the negative selection process are responsible for the host having an autoimmune disorder, and that can be like type 1 diabetes. So if there was a problem in negative selection, that can be a reason for autoimmune disorders or diseases. It is likely that most negative selection occurs through a process known as clonal deletion, where high affinity TCR interaction directly induces apoptosis signals. So if there is a signal for clonal deletion, that's basically apoptosis. Thymic dendrite cells and macrophages, which are found in multiple areas of the thymus, clearly have the ideal features to mediate negative selection, but so do epithelial cells, which express high levels of which express high levels of the costimulatory ligands CD80 and CD86, as well as the unique transcription factor that allows them to present the tissue-specific antigens. And so, therefore, both the cortex and the medulla have the potential to induce negative selection. So, just to go back a little bit on what we talked about, I don't know what just happened, but the negative selection, if it's not 100% right, or if something goes wrong, that can cause our bodies to have a problem or an immune disorder. And then positive selection, basically, you have to go through positive selection to get to negative selection. So we have to have both of those to be able to, get through our systems and to help us to be healthy.